Assalamu alaikum. My research title is a hybrid ultrasonic membrane anaerobic system in treating wastewater with increasing energy crisis and prices and drive to reduce carbon dioxide. Alternative energy sources are highly demanded, and currently the type of all the type of the waste, whether is that is the palm oil waste or sewage sludge wash or sugar cane waste or the slaughter wastewater or palm oil mill effluent, all these wastes are very high, contain very high biological oxygen demand, chemical oxygen demand, total suspended solid, volatile suspended solid. So the environmental rules and regulations do not allow to discharge all these wastes direct to the environment or to the land or to the lakes. So the current technologies or the methods used to solve the waste treatment, they use open tank, open land, open bond, which is in terms of the economically, yes, they are less in terms of the economic. However, the main issue of this, how to retain the CH4 and also how to solve that problem, because the disadvantage of all this, there is a lot of odor, they occupy a lot of land area. Also, there is problems in order to capture the methane gas. The novelty of our research is how to retain the CH4 from this waste, also how to occupy the reduce the duration, the retention time, in order to reduce the capture the gas. And this is the novelty. So based on that, the conventional, they use aerobic, which they use a lot of oxygen, and that is a prolong the time for the microorganisms to acclimatize to the system in order to treat the waste. But that problem, they use a lot of research area, very large research area. So our system, based on that, we came with a novelty design with so the industrial, they move from aerobic to anaerobic. At least the purpose, they moving from aerobic to anaerobic in order to capture the methane gas, which is they introduce the industrial, they introduce the methane the membrane in order to retain or to capture and that is good. But the problem of the when you use the membrane, the fouling problem. So that is the main now current issue with the industrial. So use the membrane, but the fouling problem, when that problem is occur, you have to stop the system. Then we flush, they take out the membrane from the membrane housing with the cleaning with the chemicals and also with the water. So that is caused because of cleaning using more chemicals, maybe the damage the surface of membrane. Also, when you stop, if you're an industrial and you stop your system for 24 hours for the cleaning purposes, they are going to lose a lot of money. So as alternative cost effective, this invention, we are introduce 6 transducer, design 6 transducer along the membrane. So we have ultrasonic, that ultrasonic covers the membrane. They create mechanical energy along some surface of the membrane, so they clean the membrane continuously. So in our system, we don't stop the system, and continuously is continuous cleaning the system of the surface of the membrane, and membrane is a very efficient in order to run. So our system, first of all, we reduce the advantage of our system with introducing ultrasonic. We capture the methane gas because there is no fouling. We solve the fouling problem. We reduce the land area from, because in the conventional they use a half football field, very occupied, large. So we reduce it into vertical. Also, the conventional, they need at least 60 days in order to capture the gas. Our system only 21 days. So we reduce from 60 days to 21 days to capture the methane gas. And that is the novelty of our research. And this is our system. Is quickly, if you see, I explain you the system. So we have, this is the reactor. So we pair the waste in this reactor. We have the pump. The pump take the waste from the system to the membrane. Then the membrane is cleaned. The untreated is called the retented. The untreated is back to the reactor. The treated is going to recirculate. Then the gas, we collect the gas from the top, from that line. If you see this line, yes, we collect the gas from the top. And that is the one of the significant and novelty of this work. We are able to retain all the gases, and that is the difference between our system and the conventional systems of that one. Also, we reduce the retention time for the capture of the gas from 60 days only to 21 days to capture all the gas. Also, the system is very sufficient to treat 4 types of the waste: palm oil mill effluent, sugar cane, sewage sludge, and slaughterhouse wastewater. From all these type of the 4, we are able to retain the methane gas and reduce the carbon dioxide with introducing the potassium hydroxide. The potassium hydroxide to absorb the carbon dioxide, CO2. The remaining is a pure CH4, and that is the novelty of the work. Thank you.